Okay, on number 9 on your Chapter 12 review, it says on number 9, by examining past tournaments, it's possible to calculate the probability the school wins their first game in the National College Basketball Tournament. Each school's rank going in the tournament is a strong indicator of their likelihood of winning their first game. This can be expressed as y equals negative 6.44x plus 100.5, where x is their rank out of 16 and y is the percent chance that they have of winning their first game. Using this model, the school rank number 14 has what probability of winning their first game? Round your answer to the nearest percent. So they're going to give you a little table right here. Their rank is 2. They have a 93% chance going on to the next one. 4 is 76%. 7 is 60%. Their rank is 8. 56% probability. 9, 46%. And 10, 39%. Well, from that data, they actually found this equation right here. Y all equals negative 6.44x plus 105. All we have to do is just remember x is their rank and y is the percent chance they have of winning their first game. So in this problem right here, it's just an actually matter of substitution. So on this problem right here on number 9, all we have to do is just go ahead and substitute in 14. And because that is the school ranking, we just have to put that in place of x, because x is the rank. So we're just going to substitute that in. So we've got y all equals negative 6.44. And in place of x, we're going to go ahead and put in 14, because that is their ranking, plus 105. And now I'm just going to go ahead and put that in my calculator and find out what that probability is. So putting that into your calculator, just have to type in negative 6.44, and then their rank is 14th. So we put that in place of x plus 105. Go ahead and hit enter. It says 14.84. Well, the directions say round your answer to the nearest percent. So notice I got y equals 14.84. So I'm going to round that up to y all equals 15%. So if they're ranked 14, their chance of winning their first game is going to be 15%. Okay, now this next problem right here on number 10. Number 10 says, find the range for the entire data set. So we just got to remember what the definition of a range is. So to find the range, we're just going to subtract the lowest data value from the highest data value. So that is the definition of the range. So if you look at your solution guide, it actually kind of explains that on number 10. So let's go ahead and scroll on down here to number 10. So number 10, it says to find the range, subtract the lowest data value from the highest data value. So here's your formula right here. So range, highest data value minus the lowest data value. So I just have to go back to my data and find the highest data value out there and the lowest data value. So as I look at all my data, there's a lot of data here. I got 52, 55, 40, 46, 52, 56, 42, 68, 68, 52, 68, 62, 48, 40, 57, 45, 75. I've got 70, I've got 49, I've got 49, I've got 82, I've got 53, I've got 64, and I've got 53. So as I look at this right here, looks like this one, 82 is the largest number. Just look over all my data, double check it. Yep, it's going to be 82. So 82 is my largest data. So I'm just going to have to subtract my smallest data. So looking over all my data, I'm going to see if I can find the smallest one. So this 40, double check, just looking over my data to see if anything's smaller than a 40. I'm looking for anything in the 30s, and I don't see anything. So I just found my smallest, so 40. So 82 minus 40, and so that range is going to be 42. So that would be the answer to number 10. Okay, now number 11. It says find the standard deviation for the data set. Okay, now when you look at your solution guide, you'll be able to use your formula sheet on your test. And so the solution guide just reminds you that tells you how to find the standard deviation. So we'll just go through it step by step, just like it is on your formula sheet. So it says follow the formula sheet to find the standard deviation. Okay, so on your formula sheet, the very first thing it says is to find the mean. So remember, to find the mean, you're going to go ahead and add all your data together and divide by that number. So if you look at number 11, the data that was there on number 11, got a 4, a 6, a 5, a 9, a 5. So I'm just going to go and find that mean. So if I look at my solution guide right here, I'm going to add 4 plus 6 plus 5 plus 9 plus 5. So I'm going to add those together, and I'm going to divide by 1, 2, 3, 4, 5 pieces of data. Put that in my calculator, comes out to be 5.8. Okay, once you're done doing that, step number 2 on your formula sheet says find the deviation of each mean. And that's abbreviated x minus x bar, and x bar, remember, is your average. So notice I take that first set of data, I take 4 minus 5.8, I get negative 1.8. I take the next set of data, which is 6, and I take 6 minus 5.8, I get 0.2. I got 5 minus 5.8, I get negative 0.8. I take 9 minus 5.8, I get 3.2. I take 5 minus 5.8, I get negative 0.8. So that's step number 2. So then step number 3 tells you to square each deviation. So I'm going to take this number right here, negative 1.8, and I'm going to square it. So that's 3.24. I'm going to take 0.2 and I'm going to square it. That's 0.04. I take negative 0.8 and square it, I get 0.64. I take 3.2 and I square it, I get 10.24. I take negative 0.8 and square it, I get 0.64. That's step number 3. Step number 4 on your formula sheet says sum the squared deviations. So you'll notice I took all these numbers right here, and I'm going to add them all together. I'm going to take this number plus this number plus this number plus this number plus this number. I add all those together and I get a total of 14.8. Okay, the next step, number 5, says divide this by n minus 1. So notice that's the number of data values. So I count them up, 1, 2, 3, 4, 5 data values. So I substitute that in, so that's 5 minus 1. So I take 14.8 divided by 5 minus 1, which is 4, and I'm going to get 3.7. Now step number 6 says take the square root of all this. And so this is how it's all abbreviated when getting your statistics class. Square root of 3.7, and that comes out to be 1.92. So that's going to be the answer for your standard deviation on number 11. So the answer comes out to be 1.92. Okay, now this next problem, on number 12, let's just see what our review says. It says solve the following. It says the scores on the test are normally distributed with a mean of 70 and a standard deviation of 8. Find the score that's 2 standard deviations above the mean. Well, my mean is 70. Has a standard deviation of 8, and then wants to know what the score is 2 standard deviations above the 70. So I just take 2 times 8, which is going to be 16. So that's 70 plus 16. And so that answer looks like it's going to come out to be a total of 86. So that would be my score, that is 2 standard deviations above my mean. Number 13 says the ages of people in a retirement community are normally distributed with a mean age of 68 years and a standard deviation of 4 years. Use the 68, 95, 99.7 to find the percentage in the community whose ages are between 68 and 72. So you can notice that when you look at your formula sheet, so I'm just going to go ahead and bring up my formula sheet right here. Let's see if I can find it real quick. Which kind of reminds you of, let's see here, what that distribution is, because it will be on your formula sheet right here. So This is kind of how it breaks down right here. 68% of our data lies within one standard deviation on each side. So one above and one below. The next one is 95% lies within two above and two below. And then the next one right here says that we have 3 standard deviations above and below. Well, 99.9% of your data falls within that. So if you remember back to your problem that we just looked at, it said that we have a mean of 68 years and a standard deviation of 4 years. So that's going to be, notice, between 68 and 72. So if I take 68 plus 1 standard deviation, that is equal to 72. So I'm looking at the data that lies within the mean, which is 68, and 1 standard deviation above it. So how does that correlate to our chart right here? Well, here's our chart right here. So here's my mean, which in this case, on this problem right here, was a total of, on number 13, looks like it said that it had the mean that was equal to 68, and one above was the 72. So we're looking at this piece right here. I need to know how much that piece is. Well, both sides have a total of 68%. I just want this little piece right here, which is what I'm looking at, the one above. I'm just going to take 68, divide by 2, and that's going to come out to be 34%. So I'm kind of trying to explain that to you on number 12. Sorry, number 13 on your formula sheet. It says use the fact that 68% from the 68, 95, 99% rule of the data lie within 1 standard deviation from the mean. So between 68 and 72, 68% of your data lies there. So you just take 68 divided by 2 and you get an answer of 34%. Okay, now on number 14, it says that we have, says a set of data items is normally distributed with a mean of 50 and a standard deviation of 5. Convert the score of 58 to a z-score. So just remember on your formula sheet, you can find your z-score formula. And so your z-score formula, it says on number 14, the z-score formula off your formula sheet says find the z-score. It's going to be equal to your data item minus the mean all over the standard deviation. So it's actually just a matter of substituting and solving it. So notice your data item is a 58, so I'm just going to take 58 minus, has a mean of 50, so minus 50, and a standard deviation of 5, so I'm just going to divide by 5. So 58 minus 50 is going to be equal to 8 divided by 5. And I'm just going to take my calculator and take 8 divided by 5. So on my calculator, I got 8 divided by 5. And that comes out to be 1.6. So this one has a z-score of 1.6. So on number 15, I want to erase this a little bit, clean it up just a little bit here. On this next one, on number 15, it says that we have systolic blood pressure readings are normally distributed with a mean of 121 and a standard deviation of 15. Use table 12.17, find the percentage of people with the following blood pressure readings. So below 148. B is going to be above 133, and then C is between 145 and 157. So remember the very first thing that you have to do on number 15 is go ahead and find the z-score. So that's what I do on the solution guide. I'd show you. It says you need to find the z-scores for each of the problems and find the correlating percentage. which represent percentage below that score. So the very first thing I do is to find the z-score of 148. So I take 148 minus 121 divided by 15, and that gives me a z-score of 1.8. So now that I know that, all I have to do is just go to my chart. So let's see what our chart has. Go find our z-score chart and find that correlating 1.8. So here's my z-score chart. And remember, it's on your formula sheet. All you got to do is just go ahead and find 1.8. So I found 1.8 right here, and it correlates to 96.41. So remember, these charts are below, the percentile represents the percentages below that score. So in other words, that answer is just going to be exactly 96.41. So that's the answer to A, 96.41%. So now on B, it says above a 133. So when you look at your review, so notice this one was below, so that's why I could just use that z-score. This one's above. So now when I find that answer, I'm going to have to actually subtract it from 100%. So first off, I find my z-score. I take 133 minus 121 divided by 15, and I got 0.8. So when I go to my chart, and I go to 0.8 and find that correlating score, so 0.8 right here, looks like it correlates to 78.81. But remember, 78.81% is below, and in actuality that's asking for above. So remember, the question is above. So since it's above and your total percentage is 100, you're going to have to go ahead and take that number and you're going to have to subtract it from 100. So notice I took my 78.81, I subtract from 100, and I get 21.19. Okay, now to find the ones that are between. So you're going to notice the next one on C says between 145 and 157. So you got to go ahead and find those two numbers between those. So when you find those between those right there, you can find the z-score. So notice I found the z-score of 157 by using my formula. I take 157 minus 121 divided by 15. I got a 2.4. Then I take 145 minus 121 all divided by 15. I got a 1.6. So then I go back to my chart and I find those correlating scores. So notice I've got a 2.4 for the one. That's 99.18. And then the other z-score was a 1.6. So notice that is 94.52. So to find between, you're just going to go ahead and subtract those two percentages. So notice on my solution guide, that's what I do. I'm going to go ahead and take the 99.18 that I found for that z-score, or sorry, that percentile for that z-score, 94.52 for that percentile, and I'm going to subtract those two, and it comes out to be 4.66%. And so that's how you find all the answers to number 15. Okay, then on number 16, it says it wants us to construct a scatter plot on number 16. So as I look at the direction of number 16, it says construct a scatter plot and find the correlation coefficient and the equation of the regression line. So the very first thing I want to do is I just want to go and do my scatter plot first. So I'm just going to plot these. So I go to 500, and I go to 1200, and I put a dot there. I go to 100 and 500, and I put a dot right there. So that's about halfway in the middle. And then I go to the next one. I got 300 and 600. I put another dot right there. I go to 100 and 500, and I put another dot right there. It's the same as the other one, so it's right on top of it, so you wouldn't be able to see it. So I go to 200 and 800. I put a dot right there. I go to 500 and 1200 and put a dot right there. You won't be able to see because it's already on top of itself. It's already another data point. So I go to 400 and 1000. Put a dot right there. I'm going to go to 700 and 1800. Put a dot right there. I'm going to go to 200 and 700 and put a dot right there. I'm going to go to 100 and 200 and put a dot right there. And so that's my scatter plot. Now it says find the correlation coefficient and the equation of the regression line. So to do that, remember we're going to use our calculator to do that. And so do this on your calculator. Remember how you do it. The very first thing you want to do is you want to make sure that your diagnostic is turned on. So that's what I'm going to do first. So when I go ahead and turn this on, I'm going to go to second, and then I'm going to hit my catalog. And now I'm going to go ahead and arrow all the way down to my diagnostic. I'm going to say diagnostic on. So that's the very first thing I have to do is turn that on, because that's the way that I have to be able to go ahead and find my correlation coefficient. If I don't turn that on, it's not going to show me my correlation coefficient. So the first thing I do is I notice diagnostic on. I'm going to hit enter, and then I'm going to hit enter again, and we'll say done. So now the diagnostic is on. So now that you've done that, you're going to go ahead and hit your stat key. And after you're done hitting your stat key, you can go under edit and you're going to hit enter. Now if there is data in there, you can just hit delete a whole bunch of times and clear out the data. But now this first L1 is all my X values. I'm going to type in 500. And I'm going to go down, I'm going to type in 100. I'm going to go down, I'm going to type in my 300. I'm going to go down, I'm going to type in my 100. I'm going to go down, I'm going to type in my 200. I'm going to go down, I'm going to type in my 500. I'm going to go down, I'm going to type in my 400. I'm going to go down, I'm going to type in my 700. I'm going to go down, I'm going to type in my 200. And then I'm going to type in my 100. And so those are all my X values. Once I got all my X values in there, I'm just going to arrow off to the right. And now I'm going to put in the correlating Y values that go with it. So you're going to notice that this one says 500 and 1200. So right next to this one, I'm just going to type in 1200. Next one down says 100 and 500. So I type in my 500. Next one down says 300 and 600. So I'm typing in my 600. That goes along with my 300. Next one down is 100 and 500. So I type in my 500. I go down. My next one is 200 and 800. So I type in my 800 that correlates with my 200. Got 500 and 1200, so I'm going to type in my 1200. Go on down, I got 1000 that matches up with my 400, so type in 1000. And then I'm going to type in my 1800 that correlates with my 700. And then the next one down, I got 700, which correlates with my 200. And then I've got my 200, which correlates with my 100. Then when I'm done, I'm going to go ahead and use my calculator to find the correlation coefficient. Correlation coefficient is abbreviated in R. So now I'm just going to go ahead and quit out of it. Everything's already saved in here. I'm going to hit my stat key again. And instead of editing this time, I'm going to calculate. And I'm doing linear regression. So you're going to notice that on your directions right here, it says equation regression line. So that's what REG stands for, linear regression. So it's just number 4. So I'm going to hit number 4. Now your calculator is going to ask you which list you used for X and for Y. Because you can enter a whole bunch of different lists in here. And I did use L1 for my X list. I did use L2 for my Y list. And then I go ahead and I go down here to calculate and I hit enter. Okay, now that I've done that, you're going to notice that my R shows up. My R, my correlation coefficient, is equal to 0.95. So that's my R. And now my equation says is Y all equals AX plus B. And it tells me my A says 2.12, so I just fill that in. That's my slope, 2.12x plus my B, which would be 192.5. Slide this over just a little bit. And so that would be my equation, and that would be my correlation coefficient. And this right here is my scatter plot.